Well, good afternoon, good evening, or good morning, depending on where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a really interesting webinar on tap today, but before we get started with it, we do have a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of the event, you can access it on demand. We'll be sending out an email with a link to the webinar on demand post-event. Also, we're taking questions from the audience. So if you have a question at any time during the webinar, you can use the GoToWebinar control panel, submit your question, and we'll take probably about 10 minutes or so near the end of the presentation to go over those questions. And lastly, we do have 2 polling questions during the event, so we hope that you guys will participate and let us know your thoughts on a certain few things. Okay, with that, we'll go ahead and kick off today's webinar, the I/O of DevOps, and where time series database fits in, also known as the I/O of DevOps, solving the problem of information silos using a time series database. Our speakers today are Larry Gordon, Chief Revenue Officer at XOps, and Sean Mack, CEO and founder of XOps. And they're going to be joined today during the event by Chris Chirillo, who's Director of Product Marketing at InfluxDB. Welcome to you all. Thank you so much for joining me today.
Hello.
Hi.
All right, so Larry, I know you're going to kick things off, so I'm just going to turn it over to you and let you work your magic.
Charlene, thank you very much. A lovely introduction, and thanks to DevOps.com and the DevOps.com community, and to Chris and the team at InfluxDB. They're terrific to work with, and DevOps.com has always been terrific to work with as well. So thank you. I'm Larry Gordon.
And I'm Sean Mack.
And we're the co-founders of XOps, and we're going to be talking about data and DevOps and the I/O of DevOps and solving the problem of information silos using a time series database. We'll be looking at how you break down information silos using tools such as InfluxDB and the tick stack. Before we get formally started, I'll tell you a little bit about ourselves. We're XOps, and XOps helps companies and other solution providers run their technology more efficiently and more effectively. We build open source tools and offer a suite of related services to help your businesses. Our services include DevOps consulting, tool implementation, and outsourced Tier 1 and Tier 2 managed services. Like I said before, Sean's the CEO and I'm the Chief Revenue Officer. So a quick overview. We'll, very much as we've been trained, we'll do our problem set. We'll state our problem that we're trying to solve. We'll talk about how to DevOps your data. And of course, we're all pros on here. We're not actually DevOpsing the data, but applying DevOps methodologies to data problems. And we'll talk about how we do that with clients and with our methodology. And we'll talk about where do we go from here, what we can do and what people can do and what InfluxDB can do. So Sean and I did a little bit of primary research to kind of set the stage on why, how big this problem is. We see the problem in our practice and in the InfluxDB customer set, but how widespread is this problem throughout the industry? It turns out data shows that it's huge. 26.5 billion in revenue is lost each year from IT downtime. And in fact, downtime isn't the only cost sink here. Another study said that 78% of downtime costs relate to reduced worker productivity. And of course, if your website is down, if your storefront is down, you're losing revenue as well from that. So it's a big, big problem. Missed sales opportunity and worker productivity. So a bit of the challenge is, what's causing this? Massive data growth is causing this. Monitoring tool proliferation is causing this. And Now I turn it over to Sean. I think we did a poll here, a little bit of a poll. See what our poll comes out to be. I don't see the poll on my screen, but Sean's going to talk about the challenge and in DevOps how there's a lot of focus on the deployment pipeline, but that DevOps folks also need to focus on the data silos as well. So Sean,
I'm sorry, I don't mean to interrupt here, but I do have the poll if you want me to push it out for you.
oh, I'd love for you to push it out.
Awesome. All right, great. So there it is.
Yeah, there's our poll. Great, thank you.
Larry, you're too quick on the uptake there. You gotta give me a second to get the poll up.
I'm
for you.
so sorry. I'm talking fast.
No problem. So for those of you playing at home, how many monitoring tools are you currently using? Select one of the following. You can do 1, 2 to 5, 6 to 9, or 10 or more. So we'll give you guys a couple more seconds to submit your response, and then we'll take a look at the responses. Excuse me. Also, while we're waiting, I do want to remind the audience, if you have a question at any time, go ahead and use your control panel. Don't wait until we get to the Q&A. Just use your control panel and submit your question anytime. Okay, I'm going to go ahead and close it out right now, and we'll take a look at the results. Oh, wait, where we go? Okay, sharing the results. There we go. Okay, it looks like the majority of folks are using 2 to 5 monitoring tools, which seems like it might be a little excessive, but I'm not entirely sure. What do you guys say?
Charlene, our research says that's right on the money.
Okay.
Right on the money.
Very interesting.
Yeah, that many organizations, and obviously particularly if you're a larger organization, has several monitoring tools. And it's a lot for engineers to deal with. Multiple screens, multiple data feeds, people getting different sets of information, some people having particular monitoring tools, others using different ones and getting different data.
Yeah, so, well, I'm gonna go ahead and hide.
Looks like we really have the right audience here to talk about
Yay.
the challenge of too many monitoring tools.
Excellent, excellent. Well, I'll let you get back to it.
Thanks. That was fun. Sean, you want to take over from here?
Excellent. Thanks so much, Larry, Charlene. Yeah, that's great information. Thanks for your feedback in the audience. And right in line with a survey that was done by App Dynamics says the bulk of people responding that they had 6 to 10 or 11 to 25 tools. And this is a growing problem when you try and manage increasingly complex, infrastructure, cloud, hybrid environments. As Larry mentioned, in DevOps, there's a lot of focus on the deployment pipeline, on automation, continuous integration, continuous deployment. But the reality is a lot of what we face in terms of the problems are after that deployment pipeline is done. And the reality is that no matter how good your deployment pipeline is, you're going to run into problems. And you need to be prepared when those come up. And a key to making sure you're prepared is having the right, not just the right tools, but the right combination of tools and the right architecture. So what we're going to talk about today is looking at a bit about how you manage kind of this massive data growth, the proliferation of monitoring tools, and how you break down some of the information silos that may result as a consequence of the increased number of tools we've got out there. So, similarly in DevOps, we talk a lot about organizational silos, but we don't talk that much about the informational silos. But I've seen these every day in our business and working with our customers, whether that be the traditional kind of silo of data where the business users have access to information about revenue, about leading indicators on sales, and tech users have information about, code performance, about performance in production, about number of defects, about number of incidents. So there's that division, but there's also divisions within the technical teams, whether that's the traditional ops has data about one thing and dev has data about another thing. but also, you know, even down to different teams within those groups. I've seen plenty of times, I've been on late night incident calls where you've got the network team saying, hey, everything looks fine for us, and the database team is saying everything looks fine for us. But the bottom line is there's a problem and it's impacting your customers. And if the teams are not looking at the same sorts of data, it can cause real problems and actually enforce these silos that we've seen in traditional ops organizations. You know, this was this is a problem we've all seen emphasized in the DevOps handbook by Jean Kim and Jez Humble, Patrick Dubois, where they wrote, for decades, we have ended up with silos of information where development only creates logging events that are interesting to developers, and operations only monitors where the environments are up and down. They go on to say, as a result, when inopportune events occur, no one can determine why the entire system is operating as designed. This sort of siloing of data can really undermine the steps towards cooperation that we're taking in our effort to do DevOps transformations. So, you know, I've experienced this far too many times. I had one great example I'll tell you about where I experienced this. We had a system where an incident where one of two revenue processing systems was down for over 48 hours. That meant that customers, that 50% of customer transactions were failing for almost 48 hours. Now you say, how could this possibly happen, right? How does this happen? Well, the reason it could persist for so long was because of the siloing of data. The finance team that looks at those revenue was only looking at revenue data once per week. So they weren't looking at the data that shows clearly there was a drop off. The systems team that was looking at system level data did receive alert, but they assumed naturally that it was a part of a redundant system. But the way the system was designed, customers were routed to one or the other server. So customers who were routed to the failing infrastructure did not get a successful transaction. And the customer service people who also had data on this were so busy responding to angry customers and naturally assumed it was also due to the uptick in customer requests as it was peak season. And they had no time to actually draw it back to the underlying infrastructure problem. So clearly a way in which the siloing data significantly impacted the bottom line for a customer.
I'm still finding it difficult to believe that's really you, Sean.
Yeah, it was a while ago, Larry. I've lost some weight since then and got in a new computer.
That's so hilarious. I love watching that. I could do it all day.
I definitely identify with the frustration. So let's talk about, we talked a bunch about the problem. Let's talk a bit about what are the solutions. I'll look at several different ways we can solve this. Like, firstly, determining what your data sources are and reduce the duplications. Secondly, you want to centralize key data. And finally, you want to up-level your data and provide actual valuable information to all of the people, tech users and business users, ops, dev, alike. Let's get into some more detail about how we do each of these. So first of all, determining data sources and reduce duplication. So I strongly advocate looking at where you do have duplication in your monitoring data sources and reduce it, right? Now, I don't advocate a one-size-fits-all. A lot of vendors out there are saying, hey, just use our tool for everything. But what I found in going through the market is that there really are vendors who are great in certain things. And so I think you want to find best-in-class tools for each major area that you need to cover. But at the same time, you don't need 2 or 3 tools for those areas. I worked with one customer that had over 50 different monitoring tools. Server space alone, they had 5 to 10 different tools, right? And this is a really mature area for monitoring. And all of them, while slightly different, did 80 to 90% the same thing, right? So while we can get into these somewhat religious debates about Nagios versus Zabbix versus Xenos and which is best for monitoring your CPU, I think the important thing is to make a firm decision about which one you will use and standardizing on that. Not only does that ensure you're getting cleaner data in, it makes your systems vastly more manageable. It means that someone managing one application can easily manage a different application if it's monitored with the same tools. So I'll also say that this is going to be dependent on the number of people, the size and maturity of your organization. Many smaller organizations, startups, can get away with just a couple of key monitoring tools. And in fact, if your organization is small, you may benefit for finding tools that can handle multiple different aspects of your monitoring. Maybe you want to look at one tool for handling all of your kind of inside out infrastructure or cloud monitoring, and another for monitoring all your outside in, like your synthetic monitoring type transactions. As you get more complex, as your infrastructure gets complex, more complex, as an organization gets larger, you're going to have increased diversification of your tool set. So it's going to be dependent, and you're going to have to find the right number that fits for you. But I think the key here is to make sure you don't have the same tools doing the same thing in different ways. In that, with that same customer who had 50 plus tools, we'd even have the same tools monitoring in different ways in different locations. So a red alert in one area meant something completely different than a red alert on the same tool for a different data center. So by standardizing, you increase manageability and have taken a first step towards bringing your data together in a cohesive way. So that leaves us to the second place, which is put all your data in one place, right? This includes reviewing your data architecture to determine what all your data sources are, bringing them together. You also want to look at correlation tools and tools that can bring all of this data together. Influx, which we're going to talk about, is a great tool that can bring a lot of your time series data together, really provides some of that value. The other thing, but there's several other tools that can do that. So you want to determine the right one, the one that's right for you. And as I mentioned, in reducing duplication, you're also going to want to clean up the data sources, figure out what your standard input formats are. Get it so it's as clean as possible coming in is going to make it that much easier to manage it and really get a strong set of data which you can work from. Once you've determined your architecture, cleaned up your data sources, cleaned up your input sources, you want to pipe all your data into one place. Now, I will also say that this is easier said than done, right? Most data sources are designed for a pretty singular purpose, and that's to be the source of data for the tool that you bought, right? A lot of vendors will not want to share that data with other tools and will intentionally or unintentionally obfuscate that data. And then you also have to be aware that there's a lot of different data types, so you need to figure out an architecture that's going to handle that, everything from logs to events to metrics. And in addition to the technical challenges, there's also organizational challenges. So this is not easy step. Now I've told you you can get it done. It takes some work, but it's really valuable to bring your organization, to make your organization that much more effective. So finally, you want to centralize your data, and I strongly believe you want to bring it all together, and then manage access through data controls, right? So while I am a strong advocate of transparency, I do recognize that in many situations, there's data which is not appropriate to be shared with everybody, or in some situations, not even legal, right? Whether it be revenue data that you can't share in real time because you're a publicly traded company, whether it be PII information that you obviously can't share. All of that needs to be obfuscated. But the way to do that is through access controls to that data, ensuring the right people have the right access to the right data. And that way, at least everyone is starting from the same data set and getting the same shared vision, even if they can only see 90% of the overall data set. That can be hugely valuable as well. So finally, once you've cleaned up your data sources, got it going to one place, you want to actually up-level your data and transform it from data, which is just the raw data, to information, to knowledge, to intelligence. And that's taking your data from raw information or raw data and really making it something that's informative to your business, something that your business can make decisions on. And this is the key, and there's several ways you can do this. One way is to look at service maps. If you're actually mapping out your infrastructure in a dynamic way, in a static way, and you can correlate the events that are coming in, the data that's coming in to those service maps, you can get some real information about how your actual applications are performing. So if you can correlate, say, data, your synthetic monitoring data with your infrastructure monitoring data with each individual application that you manage, you can paint a much more full picture of how your applications are actually performing, rather than the thin slices we get when information is siloed. The other thing that we've done a lot of thinking about is understanding the overall health of a service or application. And that means what are the components that define how well it's behaving? One thing we found is that not only is this complex, but it also varies from person to person. The definition of health of a system or service or application may actually differ from one person to another person in an organization. For example, we found in one organization that from a business user's perspective, the health of a given application really depended on, hey, can users access it? Are all the features available? And is it responding within the given parameters, right? Is it responsive? But from a tech person's perspective, someone who's actually managing that application, same application, if several of the nodes which the application resides on are having trouble, are flapping in and out, that's a clear indicator that it's actually not in good health. So in that one example, you've got the same application, two different groups within one organization who have a different definition of health. So what I advocate is making sure you have systems that provide a very flexible way of defining health, that you understand what health means, and that you can bring this data in and map it to health equations to provide a clear picture of how your applications or services are performing, and present that out to the different users of this data. Finally, there's some real cool stuff going on with machine learning, predictive analytics. And if you can bring in not just your system data, not just your cloud health, not just your synthetic data, but also information like incidents, right? And changes. Also information like even social indicators, you know, what's going on with your brand in Twitter, and bring that all together. You can begin to use machine learning to actually predict when incidents occur. By looking at large masses of data, you can say, well, last time we had the system can begin to say, last time we had this sort of pattern with these 3 variables, we had a major incident. Hey, maybe something's going to occur. You should take action before the customer is impacted. So by bringing all this data together and then providing machine learning, predictive analytics on top of it, you can actually begin to address issues before they impact your customers, and that's really where intelligence and vision kicks in. So that's a little bit about how to break down some of these information silos. I'll talk more about some of the gotchas that may go on and when implementing this sort of thing. But before I do, I'm going to turn it over to the folks at Influx to talk a bit about their time series database and how it fits in.
Awesome, thank you very much. So some of you may be familiar with the TIC stack, and maybe many of you are not. Basically, the TIC stack is a set of open source projects that you can find on GitHub or on our website at InfluxData. And the 4 open source components are Telegraph, InfluxDB, which some of you may be familiar with, Chronograph, and Capacitor. And essentially what this stack allows you to do is to be able to collect the metrics and events that you might need to be able to monitor these systems so you can ensure that your customers and your users have a really good experience with whatever service and products that you offer via the web or your smartphone apps, etc. Some of the cool things about the TIC stack is that it's actually really easy to use. And I know everybody says that, but it's actually one of our core company values, that we make sure that we really make it so that you don't have to do a lot of work to get it up and running. It's quick to install because there's no external dependencies. It's easy to just start putting in the data. It's horizontally scalable. You can just use the database component, or you can use all 4 components. It's completely up to you. And also how you want to pull the data into the database is completely up to you. So if you want to use our Telegraph agent and collect metrics and events from the various components that you want to be monitoring, from a database, from a server, from a container, you can do that. Or we can also use our service discovery module, so we can just look for the metric and events that are needed in order to be able to get that holistic view of what's going on in your infrastructure. Next slide, please. So the reason that we actually built this entire stack is that we wanted to make sure that we could build that common platform for you to be able to gather all kinds of metrics and events. And I keep stressing that we want to allow you to gather metrics and events, because the way we look at the type of data that you're collecting, metrics are something that you will gather that's on a regular heartbeat. So you're checking to see, how well the CPU is doing on a millisecond interval, whereas an event is going to usually be something that was unexpected. So all of a sudden there was a spike in usage, or all of a sudden the disk was running out. So those are things that happen at irregular intervals. And understanding both of those kinds of data points are really what's going to help you to determine what's the real health of your overall system, and also help you to start to make some predictions about what's going on. And we actually see a number of our users using this in 3 different key areas. So with today's talk, most of you are probably looking at using this kind of a monitoring platform to be able to understand how well your infrastructure is doing that's supporting your application, or even your application components itself. So we help a lot of users look at the statistics, the metrics and events I've collected from their network infrastructure, from their cloud infrastructure, from their containers, from their orchestrators, from their apps, etc. all the way into maybe the specific code snippets within their application. So maybe there's a little bit of JavaScript that you've written and you want to be able to take some measurements. So that's a very typical use case that you can see on the middle left-hand side. But we also do have a number of users that also collect a number of metrics from IoT sensors in support of consumer IoT sensor applications. So it could be any kind of a wearable that's measuring your heartbeat or how many steps you've taken, all the way to measuring in the more industrial IoT scenarios, looking at valve, if the valve, the pressures of, or the levels of the valve, is the valve open or closed? Was the pressure of a certain thing at a certain level, the water pressure or the oil pressure? Is this pump actually, working at a certain level? And then the other use case that we typically also see are going to be in business metrics. So this is going to be using the platform to gather real-time analytics about, is how many people are actually trying to get logged in. One of the funny indicators that I hear a lot of users actually use is they'll actually measure how many times somebody is resetting their password for two reasons. One, it's for a security perspective, because it might be an indicator that there's some bad things happening, someone's trying to break in. But a lot of times when users are trying to log into a system and they're having problems with logging in, what's interesting is they often think it's their fault and believe that they entered in the wrong password. So they'll hit the reset password link because they desperately want to get in and they're trying to get in. And so what a number of people do is they actually will track those kinds of metrics as well, because they actually can be a leading indicator of something that's not working underneath. And it's actually not the user's problem, but ultimately could be a problem with the infrastructure. And those things can then ultimately lead to how many people actually went through your services and completed a task, whether it's like completing a shopping cart transaction or downloading something or triggering a report, etc. Those are all important indicators for you to make sure that you can support your businesses and really achieve those SLAs that your management team have set. And so we've already heard that it's important to have a common view of all these things. And so because our platform is so flexible, we often find that a lot of users are actually using this platform across these various use cases. And then tying that with some other technologies like some machine learning or any kind of a AI component to really then dig further into trying to understand what's going on with their infrastructure or their applications. Next, please. So a couple other key points that I do want to point out about our platform. We are, at the heart of our platform, we have a time series database. And the reason that we have a time series database is if you think about these metrics and events, all that data is time-stamped. And there's a couple of key factors to consider when you're looking at timestamp data. One is when you're collecting timestamp data, it's going to come in a lot of points. Just trying to collect data at the second level or the millisecond level, just do it for a day for just a couple of metrics, and you can quickly see that there's all of a sudden huge volumes of data that are coming in. So it's important for a time series database or a time series platform to be able to handle that and ingest that in a timely manner. At the same time, you're going to want to be able to query that. So it's important that you can also query that data as it's coming in, so you can get a really good understanding of what's happening in near real time of your infrastructure, your application. And then also, we help you to automatically evict some of that data over time. So maybe you're collecting that information at the second level, but maybe after 2 months, 3 months, or even a year, maybe you just need to understand the shape of the data for forecasting purposes, and you actually don't need it at the precision that you collected it. So being able to automatically evict some of the data, but yet have still a good understanding of what was happening with that data set is important. And then we also do some compaction of the data as it's coming in, so we can help you make sure that you can manage your storage costs. So those are some of the key implications to consider when you're looking at a platform for collecting this kind of data. Next slide, please. So just a little bit more detail on the 4 components of the TIC stack. So TIC is Telegraph, InfluxDB, Chronograph, and Capacitor, TICK, 4 open source projects available for download for free. Majority of our users actually use just the open source bits and are able to do some pretty phenomenal things when it comes to monitoring their infrastructure applications, etc. So what we have on the left-hand side is Telegraph, which is a set of collector agents. There's actually over 200 now. We only wrote 7 of them. The rest were written by the community, which is really great because a lot of the community members are actually the subject matter experts when it comes to understanding the data formats for things from very specific things like databases or networks or any of those IoT types of sensors that are out there. So you can collect the data using Telegraph, throw it into InfluxDB. Alternatively, you can also just throw data directly into InfluxDB with any of our client libraries. So if you wanted to monitor the code that you've written in Java or Go, etc., you can also do that, throw that in there. And in InfluxDB, it collects it, and then you can then send that data into your favorite dashboarding tool. You can use Chronograph, which is with, one of our open source projects. Most popular dashboarding open source project out there is Grafana, and so a lot of our users will actually use that to be able to visualize and create some pretty cool dashboards that the entire organization can use to understand the health of a service that you might be supporting. And then Capacitor is a basically a real-time streaming data processing engine that you can then do to manipulate your data. So you might want to take that and try to understand some anomalies and send out some alerts. And you can send it via your favorite incident management tools like VictorOps or PagerDuty or even Slack. Or you can apply it against some code that you've written in a user-defined function to be able to manipulate that data or use some kind of AI or machine learning as well. And then you can also, if you wanted to also use the service discovery plugin, you can also, instead of using Telegraph, be able to pull some of the key metrics from things that are ephemeral in nature, like containers. And then all that stuff can then get pulled into InfluxDB. So you can take a look at all the various metrics and events to really determine what's going on in your infrastructure. So it's all open source. I encourage everyone to try it. And you know, even if you have a number of different monitoring solutions, it's worth putting this in place. You can always have InfluxDB be the central store for a lot of the other data sources that you've already got in place. And because it can also serve that data back out a number of other data sources as well. Next slide, I think that's it. Yep.
All right, Chris. Yeah, all set. Thank you very much. Yeah, great tool. Very excited about what the folks at Influx are doing. And great example of one of the ways to bring your data together. Before I get back into some of the challenges and the final wrap up, I'm gonna turn it back over to Charlene. I believe we have a final quick poll.
We do. We have one more poll, which I'm launching right now. Does your current primary solution provider have the ability to help you right away with DevOps? Yes or no? Simple, simple, simple. So we'll give you guys a couple seconds. Also, we've gotten in a couple great questions so far for our panelists, but there's lots of time. If you do have a question for Larry or Sean, or even Chris, feel free to use the GoToWebinar control panel, submit your question, and we will take a look at those very shortly. Okay, we are about 5 seconds away from closing out the poll, and then we'll take a look at the results here. So I'm gonna go ahead and close it now and share the, darn it, it happened again. Share the results, there we go. Okay, looks like the majority of folks said yes, their current primary solution does have the ability to help them right away with DevOps. Larry, what do you think about these results? Is that in line with what you're seeing, like the last one?
It's about in line with what we're seeing. A lot of people are coming up to speed with DevOps. Still, there's, I think, a long way to go. If someone said, your primary, solution provider, can they do application development or,
right,
infrastructure? It'd probably be 90%. So,
yeah. Okay.
So I think we have a ways to go, and that's what we're
Why you're
participating.
here. Exactly. All right, I'm going to hide these
Thanks for doing that,
results.
Charlie.
No problem.
Excellent, excellent. All right, great. Thanks so much. And so, I do want to say that as you're going and looking at a tool to bring all your data together, there are some things that you want to be careful of. The first I'll say is stay away from point solutions where possible, right? So often when I'm, helping a client, I'll have people come in and say, hey, we've got this new tool. And I often use a evaluation criteria of, can it solve the same problem in other places, right? If it's monitoring CPU, for example, can it work for can it work for Windows systems as well as Linux systems? Because that's a pretty general problem. And if you've got to have one solution per OS, you've just, in complex environments, tripled or quadrupled the complexity of your monitoring solution. So where possible, avoid point solutions. I think this is particularly applicable when you're looking at hybrid cloud environments, to see if you can find a solution that will solve for your data center or and your cloud, right? And the more you can do that, the better. I've seen some clients where they really bifurcate their operations and say, oh, we're going to have one team that operates and one set of tools for the cloud and one set of tools and one team for the our terrestrial data centers. And you've just doubled your complexity. So where you can, find solutions that fit a variety of needs. You also want to avoid vendor lock-in. A lot of the commercial solutions for these kind of problems, for data consolidation and presentation, a lot of the commercial vendors will lock you into their other tools and say, yeah, we can do that, we can do the correlation, but you also have to use our blah, 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 right? And so when you're looking at solutions, make sure you don't get locked into one vendor. And then also on the monitoring side, make sure you have access to your data. Like I mentioned, a lot of tools are really designed to do their one function, and in that design is an assumption that they're not going to share the data. Make sure whenever you're choosing a tool that you have access to your data so that you can begin to ingest it into some sort of correlation engine. And finally, and along these lines, ensure you have complete APIs so that you can get at the data, and even build bi-directional integration so you can work back and forth from your correlation source to these tools. The final thing that I will mention is that no tool in and of itself is a DevOps tool, right? Even, if I think of DevOps as a spirit of collaboration and building collaboration, no tool in and of itself can force collaboration. In fact, I've seen some great collaborative tools be used in a very uncollaborative way. One organization I worked with had 3 different chat tools. Their business users were using Skype, the development team was using Slack, and the ops team was using HipChat. So in that example, one of the arguably most collaborative tools, a chat application, was actually being used to enforce silos. So I strongly emphasize that you want to build a collaboration, a culture of collaboration first and foremost. Tools alone can never make you DevOps. So, talked a lot about the problem, looked at some ways. What are some concrete steps and where do we go from here? First and foremost, look at what you're doing to manage your infrastructure, what you're doing to monitor your systems, your cloud environments, identify and reduce any duplicative data sources. Along this similar vein, look at and reduce point solutions where possible, provide more general solutions that can solve the same problem in multiple places. And finally, determine a central data collection point and presentation engine. Thank you very much. I'll turn it over now for Q&A.
Yeah, we've got, like, as I said before, we've gotten some good questions in so far, but if you do have a question for any of our panelists, just go ahead and use your control panel. We'll go ahead and jump right on in. The first question, are you able to get metrics from the following applications? Jenkins CloudBees, SonarQube, Excel Deploy, Excel Release, Bitbucket, other applications? That's a list there.
Sure. So I'd love to hear from Chris if and specific to Influx, right, and kind of the capabilities here. I think in terms of the general concept, if those are the tools, there are several different solutions. Influx is a great one. Make sure that those are your requirements going in. Most of the correlation and presentation tools out there are adaptable to handle a wide variety of set of different information.
And certainly we've seen that collection of tools in our practice being correlated and aggregated. So certainly something we've seen, yes.
Yeah, and I was just going to echo that as well. And off the top of my head, I can't remember if there are specific plugins for each of those things. You can just check on our, just go to our either our GitHub repo or our website, and you can see the entire list. I know, talking with a number of users, that CloudBees for sure, and Bitbucket, there have been a number of people who have been using Influx to capture metrics on that to understand their how well they're doing with their release cycles as well. And then, even if there isn't, chances are you just have to reach out to the community, and then we can quickly find out if someone's already built it, or they can also share with you how easy it is to actually collect the metrics from those things. The beauty of open source.
Yay, we love open source. All right, next question. We use a very outdated database in my company, and it's really hard to clean the data even if we gather it. What are your suggestions for validating and consolidating this data before, let's say, throwing into InfluxDB?
So Chris, I'll jump in there, and then you might have something to add here. But I think that a lot of times the plugins will offer some of that. I think you want to start with a data architecture, and I spoke to that a bit, where you really determine what your data sources are and what that looks like, right? And so with a lot of clients that we've worked with, the first step has been kind of to define that format, whether that be your alert formats, whether that be data coming in from a database like you mentioned, whether that be your log formats, because if it's obviously garbage in, garbage out, and I think it sounds like that's the problem you're having. The other thing you may do once you've kind of determined what you want that to look at is implement some basic collectors, which will actually clean up your data, provide it in a standard format before shipping it into a centralized collection source.
Yeah, I think that's really great feedback. I mean, you can easily throw it into InfluxDB right away. One thing that you could also do is, as you're putting it in there, you can start tagging the data, so that even though, maybe to help kind of understand, what's actually coming in, what is garbage, and maybe that will also be a good way to then go back to figure out, what's not necessary at all. So you might be able to just kind of come up with a small project to help with the cleanup of that.
Okay, great. Next question. How is Tick different from PCP Prometheus?
Yeah, great question. We get that all the time. So it's the same and it's also different. So it's the same in that, you know, both projects will allow you to collect metrics from a lot of the infrastructure components, especially when you're using orchestrators like Kubernetes or for your containers. And typically what we see happening, and actually this was on the recommendation of the Prometheus team, is that if you are using Prometheus, keep in mind that Prometheus is not meant to be a long-term store. They actually, you know, just gathering this this data, and they come from a belief that the data that they're gathering is going to be for components that are ephemeral. So they're not going to be sitting around a long time. It's containers that are getting spun up and then spun down really quickly. So they only keep data around for 2 weeks, which is going to be completely fine in order to be able to support your infrastructure. But you may also have a secondary requirement of being forced to keep that data for security and compliance reasons. And then tertiary reason might be that you need it for forecasting to understand, you know, is that infrastructure that we have enough? Do we need to use that information to figure out what we need in the future? And so what the Prometheus team actually did was they actually provided us with an API so that we could be that long-term store. So you could use InfluxDB behind Prometheus to keep those metrics and use it for those two use cases. The other thing that's a little bit different is Prometheus has typically been being used in more kind of a infrastructure application kind of use case. And so we also see people, if they happen to be, if they want to be able to collect different kinds of very more specific custom metrics, then they'll also supplement InfluxDB, at least the, you know, the collector component, and also InfluxDB, and then send that data into Prometheus to then, you know, do whatever you're already doing with Prometheus. So we see sometimes people will use it in conjunction, and then sometimes they'll just find that, you know, Prometheus is sufficient, and so they'll just use that, or the other way around. Sometimes they'll just be happy with using the tech stack for what they're doing. In either way, they're open source projects, and we are super good friends with them, and we're actually always invited to speak at PromCon. And if you want more details on how to use the two projects together, I would recommend going to the PromCon videos from last year and take a look. There's a couple of talks that actually describe what I was talking about in more detail. And then our co-founder and CTO will also be speaking in August at the next PromCon in Munich, and him and the guys over there will also be talking about what else have we been doing together. So
Great. So it doesn't sound like you'll be hurting anybody's feelings if you use InfluxDB or Prometheus.
not
Then.
at all.
Okay, awesome. All right, great. Next question. How do I query data across measurements using InfluxDB?
So I think what we'll do, Madison, is let's talk about this outside of the context of this this webinar. I think it's going to take a little bit more time than what we have designated.
All right, that's fair enough. Okay, next question. Then I think we're going to have to wrap it up. Do you have a methodology for helping? I think Larry, this one's for you, or Sean. Do you have a methodology for helping other solution providers implement DevOps for their customers?
Larry, I'll let you take that one.
Sure. Great question. Thanks, Charlene. So yeah, we do, and it's something we're finding more and more as customers are going to their primary solution provider to ask about help. And the methodology is actually pretty sophisticated because it involves working with the other solution providers pre-sales and building innovation labs, filling out architecture requests and requests for information, and then delivering DevOps solutions, including DevOps solutions that include Influx data, to the enterprise customers. So what DevOps has done is it's expanded the value chain and the supply chain for how companies reach DevOps solutions. So yeah, it's a 5-step solution that starts with pre-engagement and pre-sales and ends up with CI/CD and continuous monitoring.
Oh, okay, great. Well, that is about all the time that we have for questions. So I do want to thank everybody who did submit questions. And if we didn't get to yours, just know that the panelists will be receiving a copy of all the questions after the event. And I'm sure they'll be more than happy to follow up with you offline to get your question answered. I would, speaking of the panelists, would like to thank them for joining me today, Larry Gordon, Sean Mack, and Chris Trillo. Thank you very much. It was a total pleasure. I got a lot out of it. I'm sure the audience did as well, judging from the number of questions we got in. So thanks very much. And also would like to thank the audience for joining us today. Without you, we wouldn't be here. So just a quick reminder that the event has been recorded, so if you missed any or all of it, or you just want to listen to it again, you'll be receiving a link via email that will take you to the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always check the website there. Look under the webinars tab. We have on demand and upcoming webinars listed there, so while you're there, take a look around. Maybe there'll be something else that piques your interest. Hopefully. But otherwise, again, to our panelists, thank you. To our audience, a big thank you. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thanks for having us, Charlene.
Thank you.
Bye-bye.